In this video, you are going to learn how to identify the polarity of a molecule. Polarity means that there is a difference in charge in a specific molecule. It is a scale. There's a scale of polarity going from nonpolar all the way to ionic. And in order to determine the polarity of a specific bond, we look at the electronegativity differences. If the electronegativity difference between two elements in a bond is 0.4 or below, it is nonpolar. Nonpolar means that there's really not a difference in charge on that molecule. If it is above 0.4 and below 1.7, it will be polar. And if it is greater than 1.7, so greater than 1.7, and it's made up of metals and nonmetals, then it will be ionic. So when we look at these bonds, we can determine their polarity by looking at their electronegativities. So carbon has an electronegativity of 2.5, and hydrogen has an electronegativity of 2.1. The difference in their electronegativities is 0.4. 2.5 minus 2.1 is 0.4. Because the difference in electronegativities is 0.4 or below, this would be a nonpolar molecule. Now let's look at carbon and oxygen. Carbon, again, has a polarity of 2.5, and oxygen has a polarity of 3.5. So the difference in their polarities is 1. 3.5 minus 2.5 is 1. 1 is in between 0.4 and 1.7, and so this bond right here is a polar bond. And lastly, we have magnesium and oxygen. Magnesium has a polarity of 1.2, and oxygen again has a polarity of 3.5. So their difference is 2.3, which is more than 1.7. So this is an ionic bond. And to check that one, we can also say, oh, magnesium is a metal and oxygen is a nonmetal, so it will be ionic. Will be ionic. So now let's talk about the polarity of an entire molecule. The first question you need to ask yourself, and please write this down on page 64 in your notebook. The first question you need to ask yourself is, does the molecule have a charge? Okay, so here we have a molecule and it has a charge. This means that it's automatically ionic. If we write out the charge in the formula, okay, right here, it's ionic. So if you answer yes to this question, it's ionic. The next question you need to ask yourself is, are there lone pairs of electrons on the central atom? So now, notice there's no charge up here, so it's not ionic. So now we need to draw out our structure. We have 3 chlorines. Each chlorine gets a total of 8 electrons. And our phosphorus also gets 8 electrons. So notice we have a lone pair of electrons on our central atom. So the answer to this question is yes. That means it's polar. So whenever there's a lone pair of electrons on the central atom, we will have a polar molecule. The last question you need to ask yourself is, do the bonding atoms have different electronegativities? So when we draw this structure, it looks like this. I want you to notice there's no lone pairs of electrons. There's no electrons around our central atom. Carbon has no electrons around it. But does that mean it's nonpolar? Not necessarily. If there are different electronegativities in the atom, remember, hydrogen has an electronegativity of 2.1, and nitrogen has an electronegativity of about 3.0. So notice, our bonding atoms have different electronegativities, therefore this is polar. So if you answer yes to this question, it will be a polar molecule. So just to recap, nonpolar molecules, so for instance, carbon dioxide, has no lone pair, no charge, no lone pairs of electrons on our central atom, and these two atoms, our bonding atoms, have the exact same electronegativity. So this would be nonpolar. Another example we have is CH4. So notice, again, for this structure, there is no charge on this molecule. There's no charge here, so it's not ionic. There's no lone pairs of electrons on our central atom, and all of our bonding atoms have the exact same electronegativity. So this is also nonpolar. And our last structure is oxygen, which looks like this. And because there are only two atoms, we can calculate the polarity of this molecule by just calculating the polarity of the bond between them. So oxygen has a polarity of 3.5, 3.5. So 3.5 minus 3.5 is 0. Okay, so this is a non-polar molecule. These are all examples of polar molecules. So if we take our first one, H2O, notice there are lone pairs of electrons on our central atom. So that is so that is polar. O3, so ozone, again, even though all the oxygens are the same, they're all oxygens, there are lone pairs of electrons on our central atom. So this is also polar. And our last example is HCN. Okay, there's no lone pairs on our central atom, but H and N have different electronegativities, so this is also polar. These are all examples of ionic molecules, and I just want you to notice they all have charges. We don't even need to draw out the structures because we see these charges right here. That means that they are ions, so they are ionic. Please fill in the ionic column of your classwork.